So we all know why you guys are here. We want to learn about rational functions. What is that? Well, I'm going to tell you guys. It's going to look something like this, where f of x equals something over something. Rational. Let's use p of x over q of x as long as q of x doesn't equal 0. Because if we have a 0 in the denominator, then the whole equation will be nothing, 0. In a rational function, p and q of x are both going to be polynomials, and f of x is defined as long as q of x does not equal 0. So, what does this thing look like with some real numbers? Right here, so we have f of x equals 2x squared minus 5x minus 3 over 2x minus 5. Now you might be thinking, where do I start and where am I going to get my numbers? So we're always going to start with the denominator. We want to find the function's domain, the number that will give us a 0, because f of x will be any real number as long as q of x doesn't equal 0. So we're going to find a 0 for the denominator. How to do that? Just set x equal to 0. So we have 2x minus 5 equals 0. And we're going to get x alone. So we have 2x equal to 5. And then last step, divide by 2, get the x completely isolated. And that's going to look like x equals 5 over 2. So that means that the domain of this rational function, I'll go over here, is all real numbers except 5 over 2. So now that we have the 0 of the denominator, what are we supposed to do with the top? Same thing. We're going to take 2x squared minus 5x minus 3. We're going to set that equal to 0. Or, if it's possible, we'd like to factor it. So this is factorable. So I'm going to go ahead and do that. Alright, so the point of the factoring is we're trying to find the zeros for the top. Okay? So we're going to factor this out. Take the 2x. Let's factor. So 2x plus 1 and x minus 3. So that's the factored form. Now we're going to go ahead and find the zeros of the rational function. So same thing we did to find the 0 of the denominator. We're just going to set both sides equal to 0. 2x equal to 1, negative 1, which would be x equal to negative 1/2. Sorry, it's getting sloppy. And over here, x, well, just equal to 3. So my zeros of the function are equal to negative 1/2 and 3. The easiest way to find the x-intercept is we're going to go ahead and factor the numerator again. So what we add. So we're going to, that's how our numerator was factored. Now what we're going to do is we're going to find the zeros, or what x equals in each of those, and those are going to be our y-intercepts. So 2x equal to negative 1, x equals negative 1/2. So we're going to go ahead and put negative 1/2 as one of the x-intercepts. And then x equals 3 as our other. So that's how we have the two x-intercepts. Now let's move on to the y. Now how do we find our y-intercept? Simple, we're just going to do the opposite of what we did to find our x. Instead of putting y equal to 0, we're going to put x equal to 0. So, when x equals 0, what's the y going to be? Okay. So we have 2 times 0 squared minus 5 times 0 minus 3 over 2 times 0 minus 5. Substitute that out. 0 to the 0 times 2, 0. Minus 5 times 0 minus 0 minus 3 equal 3 on the top over here. Check the bottom. 2 times 0, 0 minus 5. We're going to stick with that. Negative 5. Oh, and this is negative 3. Negative 3 over negative 5 is going to give us a positive 3 over 5. So that's going to be our y-intercept. Now let's find those asymptotes. Okay guys, so when we're graphing a rational function, what we're going to have to do is find something called the vertical asymptote and the horizontal asymptote. And what those are, it's just really saying when we figure out our graph and everything, what two numbers we're going to have to not cross in order to have a rational function. So a rational function never crosses their asymptotes. They just gradually get closer to the asymptote, but they never actually touch it. So it should look like something like this. So say this is negative 2 over here, and that's the vertical asymptote. Now the graph will never touch that, but it'll gradually get very close to it, assuming that we have a negative 1 asymptote for the horizontal. Then this would be going like this and gradually get closer, but again never touching. So that's what an asymptote is. Alright guys, so now that we found our x-intercept and our y-intercept, we're going to go ahead and find the vertical asymptote. How to find that? We're going to set the denominator to 0 like we've done so many times already. It's going to be repetitive. 2x minus 5, 2x minus 5, x equals 5 over 2. It's our vertical asymptote. It's about 2.5. So let's go ahead and graph that. So let's see. 2.5 right here. Roughly, we're going to put a dotted line all the way there. Okay? So that's the vertical asymptote. Alright guys, hopefully you're still with me here. We found our x-intercepts, our y-intercept, we found our vertical asymptote, and our horizontal asymptote. We plotted it all on the graph. What's this thing going to look like? Alright? So, finding our first one. We use these two right here where they're going to intersect. And we have to stay true to our asymptote. The first one's going to look something like this. So, from huge value all the way, it's going to go through both of these points and shoot straight up. Now remember, it'll get very close to this asymptote, but it will never touch. Now, what are we doing with this point? It's easy. It's going to look the same as this, but just flipped around. So we're starting from all the way over here, and it's never going to touch this asymptote, but it'll get really close. Alright guys? So that's what the graph should look like if you plug your equation, your original equation, into the calculator using parentheses. This is what you should see. Probably a lot neater than my horrible handwriting. In a business setting, maybe an employer would use a rational function to see how employee A and employee B can work together, how long it takes employee A to finish a task, opposed to employee B, and if they work together on one simple equation, how long it would actually take them to solve that in a business setting. The employer is going to ask employee A and B to work together on a project. Say it takes employee A 10 hours to finish the project on himself or herself, or employee B 15 hours to finish the project herself or himself, and they want to work together, and the employer wants to figure out how long it'll take. Then we have A equals 10, B equals 15, 1 over 10 and 1 over 15. We got to find common denominators, which is 3 over 30 plus 2 over 30, that equals 5 over 30, which is 1 over 6, and this is all equal to 1 over x to see how long it'll take, which will give us x equals 6 hours to complete the project, which is less than a work day. Therefore, employee A and B helped out the company.